Hello, everyone. Greetings and salutations. This is Volts for March 27th, 2026. Should we block some sunlight to cool the planet? I'm your host, David Roberts. For decades, human beings have been running a gigantic unintentional geoengineering experiment. The combustion of fossil fuels has pumped millions of tons of aerosols, mostly sulfur particles, into the lower atmosphere, a layer called the troposphere. The particles don't stay up there long. They react with water and fall as acid rain within days to weeks, but their sheer quantity has served to block quite a bit of sunlight from the surface of the Earth. Though estimates vary widely, our best understanding is that human-generated aerosol particles have suppressed around 0.5 degree Celsius of warming. In other words, without them, we might already be experiencing the dreaded 2 degrees of warming. As fossil fuels are replaced with clean energy in coming years, aerosol particles will quickly fall out of the troposphere, and the warming that they have been concealing could come back with a vengeance, portending what could be a rapid leap in global temperatures. That is pretty grim. But what if we put those sulfur particles into the stratosphere, the layer of atmosphere above the troposphere? There, they stay longer, typically 12 to 18 months, and reflect considerably more solar radiation. We could put that sheltering blanket back into place on purpose. That idea, that huge amounts of short-term global warming and all its ill effects could be avoided with reasonably inexpensive technology, is what animates the field of solar radiation management, or SRM. My guest today, Dakota Gruener, runs a nonprofit research organization called Reflective that aims to accelerate research into solar radiation management and to ensure that it is conducted responsibly and transparently. Her group has just released a new database revealing gaps and uncertainties in the research. Today, we will discuss that research, those gaps, whether all of this can be done safely, who will coordinate it, and much more. With no further ado, Dakota Gruener, welcome to Volts. Thank you so much for coming.
Thanks for having me.
Dakota, let's start. Give us a little bit of background. What is your professional training and background, and why did you feel the need to start this organization?
Yeah, so I spent most of my career in global health and development, doing vaccine policy with the Gates Foundation, then worked in the CEO's office at Gavi, the Global Alliance for Vaccines and Immunizations, then switched gears and worked on digital privacy and digital rights. And in that work, we were doing a lot of work with UNHCR, the UN's refugee agency, and with the government of Bangladesh. And these two projects were happening simultaneously. And the work with UNHCR was really sobering because, it brought me face to face with how many people have already been displaced, and how overstretched the international system already is with that displacement. And in the work with the government of Bangladesh, we were working with them on forms of digital credentials that would work across institutional and international borders. And the Bangladeshis were frankly quite unusual amongst governments in saying that that was a critical requirement. Usually most governments were focused on, how do you prove who someone is within their own borders? And so when we pushed them on why, what they would say sort of behind closed doors was, we expect potentially hundreds of millions of Bangladeshis displaced in the coming century because of warming.
And so they're thinking already about how to just track them and
it was a bit of how do we ensure that they have continued access to the services that they're going to need.
Right.
It wasn't even a sense of tracking them, but we expect these people to be displaced. If you can't prove who you are, you're really at a loss to, access necessary services. And I just couldn't square those two conversations. We are already at sort of beyond really what the limits of the sort of international system could handle. And people are planning for significantly more displacement. And so I started waking up every day thinking, if I'm not working on climate, what am I doing with my time? And I think when I shifted then into climate, what really struck me was timelines.
Yeah.
There's sort of, even if we do everything we can and we need to decarbonize with sort of maximum effort, it's not going to be fast enough to address this. And even if we scale CDR as fast as we possibly can, that's also going to take a really long time.
That's carbon dioxide removal.
Yes. So, with sort of each of those trajectories, the question became, what happens in the near term? And of course, there's really important stuff around adaptation, but SAI kept coming up. That's stratospheric aerosol injection, one of the most researched forms of sunlight reflection. And what was striking there was, people were discussing it as a potential tool to buy time, but we don't have the evidence to really evaluate that. And we're not on a trajectory to learn enough fast enough. And that to me felt like it was it was something worth pursuing.
So you looked around. I mean, I'm sure you're aware there's all kinds of sort of geoengineering schemes, throwing stuff in the ocean and crushing up rocks. We've covered a few of them on the pod. Is the reason you went for stratospheric, what is it, SAI, whatever, shooting the particles up into the sky, is that the one that struck you as most promising, or just most near to hand, closest to being ready, most promising? Is it still, do you think, the leader of the pack in terms of sort of the geoengineering possibilities?
Yeah, so major scientific assessments describe three main atmospheric sunlight reflection approaches: stratospheric aerosol injection, marine cloud brightening, which goes by MCB, and cirrus cloud or mixed phase cloud thinning, which goes by CCT or MCT, alongside more limited sort of surface albedo modification methods and more speculative space-based concepts. And the thing is that different sunlight reflection approaches fit different goals. I think some of those interventions are best understood as targeted risk reduction tools. Surface albedo modification, for example, could be valuable for reducing urban heat. There's really interesting work happening in Australia about marine cloud brightening to protect coral reefs.
And just so all the listeners are keeping up, albedo is the sort of reflectiveness of the surface. And the idea is if you sort of replace black or dark surfaces with white or more reflective surfaces, you'll just bounce more radiation out into space.
Exactly.
You can get some local, as you say, local urban cooling with this.
Yeah. Others are candidates, at least in principle, for meaningful cooling at the global scale. And if your objective is global cooling, SAI, stratospheric aerosols, is the leading candidate.
Interesting. I want to get into the research and some of the details and what we do and don't know. I was going to ask this question later, but I might as well ask it first, since I threw this out onto social media that I would be doing this, and you will not be surprised to hear that one question above all, the top question I get back, I'm sure you've heard it a million times, and we should just discuss it right off the bat, which is the moral hazard question. This is what strikes everybody when they hear about this, is we have a way to sort of mask the effects of climate change temporarily. Immediately, people's mind goes to, well, it seems like if you did that, it would take the pressure off people decarbonizing, right? That it would give people an excuse not to decarbonize or an excuse to delay decarbonization. I know I've had these discussions before. Everybody I've talked to who's actually involved in SAI research or SRM research generally, or really geoengineering research generally, says the same thing to this, which is like, no, it's not a substitute for decarbonization. It's just to buy time. We still need to decarbonize. Everybody involved in the research says the right thing. Your website says it very straightforwardly with no caveats.
Yep.
But I guess people still worry. And I guess what the worry is, if I'm trying to articulate concretely what the worry is just that good-hearted researchers will get it going. But if you good-hearted researchers show that it works, then it's going to be taken over by national leaders that might not be so good-hearted and that might use it in this way to substitute for or escape the need for decarbonization. So I guess that's what I worry about, is not that you have ill motives or that anybody involved has ill motives now, but what will happen if it actually proves out. So I'm just curious how you think about the moral hazard question generally.
Yeah. So I think 3 points on this. The first, and maybe this is me just emphasizing what you just said about good-hearted researchers in this for, very genuine reasons. But, I care, and I think we all care about decarbonization. And, the framing is that this is a potential complement, not a substitute. And I think there is a genuine commitment to that across the entire field.
And just to make that clear, I'm sorry, this might be obvious. The reason people are worried is that this will block some heat, but it will still allow greenhouse gases to accumulate. It will still be driving ocean acidification. And if the greenhouse gases continue to accumulate, the minute you stop putting these sulfur particles up, all that accumulated warming will just come back. So this is literally, physically, not a substitute for decarbonization. All the warming is still happening. You're just sort of disguising it. The analogy that came to my mind as I was thinking about it is a rent freeze, like in like in New York, they're doing a rent freeze, which is like fine in that it solves the immediate problem, right? It stops rent from getting worse, but all the structural forces that are causing rents to rise are still operating behind the scenes. And the minute you take the cap off, it's all going to come back. So you're not solving the structural problem. I know this, you know this. I think everybody involved in SAI knows this.
Yeah. So there's interesting and somewhat counterintuitive evidence of how SAI lands at an individual level. Public perception studies, and this has now been repeated multiple times, generally find that people, after learning about sunlight reflection, do not on average show a change in their support for policies to cut emissions. Rather than people saying some version of, great, we can stop worrying, we're off the hook, they say, if we're talking about that, things must be worse than I realized.
Right. I guess if you're not familiar with this discussion, kind of the whole thing sounds crazy.
Yep. So that is one piece. I think the second piece, I found this to be a really compelling case, and it's difficult because we will have no counterfactual to kind of evaluate this against. But every climate catastrophe, floods, hurricanes, fires, requires politicians to mobilize enormous funding and political capital to respond. And that's money that's diverted from the slow, steady work of decarbonizing. And so I think there's an interesting thing to explore around whether measures like sunlight reflection, by averting some of these near-term disasters, whether they could protect the political space and resources needed for the energy transition.
Yes, because there is certainly an argument to be made that the stresses of climate change itself are going to make the political coordination to solve climate change more difficult as you get more disasters, et cetera, et cetera. So you can hold some of those disasters off. Maybe you create more space. It's really hard to predict these things. I mean, I think it's very hard to say what would actually happen if this proved
completely, it's impossible. And there is no mechanism that can guarantee that this doesn't, allow fossil fuel companies to continue emitting, just as there are no mechanism that can guarantee that carbon removal won't be used as an excuse to delay cuts. What we think we can do, though, is make the research transparent and the evidence public, and ensure that there is good information that's being generated rather than just sort of a flurry of speculation.
I mean, if there is any topic in the world that is ripe for misinformation and conspiracy theories, it is a handful of scientists trying to tweak the global atmosphere. You do need aggressive, good communication, I think. So along those lines, let's talk about the database. So the idea behind this is injecting these particles, doing this. There's a lot of things we don't understand about it. Let's get a map, basically, of what we do and don't understand. So just explain quickly the database, kind of how it's constructed.
Yeah. So first on why we built this database. At present, research into sunlight reflection, research into stratospheric aerosols is fragmented and it's underfunded. And different groups are chasing their own questions, and those are often really interesting questions, but there isn't a shared view of what uncertainties really matter for real world decisions and what it would take to reduce them. Which means that, if you're a funder thinking about funding work in this area, you have no idea where to place your resources. if you're a researcher saying, how do I spend my time? You're maybe second guessing how you choose to spend time. And I think policymakers are stuck sort of feeling skeptical of, can this ever deliver actionable guidance?
Right. I think it's worth saying up front that you say, your organization says at the top of all this, we are not currently advocating doing this. We don't know yet whether it will work or not, right? Like, so I think this is important for the audience to hear. You're not out there sort of banging the drum saying, do this, do this, do this. It says on your website, we just don't know yet. What we want to do is find out.
Absolutely. We are genuinely agnostic about whether SAI should ever be deployed. If the science says it's a bad idea, that clarity would be a good outcome. And if we have to close up shop because the science says this shouldn't be done, we'd celebrate that. What we are not agnostic about is decisions being made in the dark. The debate often flattens into this sort of pro versus con, but the challenge is that we don't have the evidence for that pro versus con yet. What matters is how fast can we get to a place where decisions on if, when, and how are evidence-based.
So you break up, I guess, what you'd call the uncertainties, these gaps, into 4 basic categories. There are a lot. I mean, there are dozens, and we can't possibly go through all of them. But maybe you could just talk about some of the big categories just to give people a sense of the kind of things researchers are looking into.
Absolutely. So we have broken it up into a few different categories of technical uncertainties. And I should stress here that we have only focused on technical uncertainties.
Yeah, that's important.
This first version does not try and tackle all of the socio-political big open questions surrounding all of this. But for those technical uncertainties, we focused on 4 categories: aerosol evolution, climate response, Earth system response, and engineering. And for each one of those, we have gone through the scientific literature to describe each uncertainty well and to place it into a pretty simple matrix, which tries to essentially rank things based on how likely are we to be wrong about this uncertainty, and how much would decision-making on SAI be impacted if we were wrong about that uncertainty.
The significance of it.
Exactly. There may be some things that we understand pretty well, so generally have reasonably high confidence on, but if we're wrong even by a little bit, that would make a big difference. There are other things where we might not understand it all that well, but it doesn't seem like that would change any decisions.
So aerosol evolution, I'm guessing, is just discussion over what kind of particles? I mean, is that a big discussion or?
Yeah. So one of the examples that I'll give here, an aerosol evolution uncertainty, is around aerosol size distribution. And I apologize, this is going to get wonky quickly.
It's fine.
But basically, aerosols, if somebody were to do SAI, would be released from a plane. And those aerosols would, actually, a gaseous precursor would be released from a plane. But those aerosols would oxidize and then coagulate. And the resulting size of the aerosols themselves really matters because it affects how reflective it is and the lifetime, how quickly it falls out. And this is something that we don't understand all that well, because while we have empirical data on aerosols and how they form after a volcanic eruption, nobody's ever intentionally gone to the stratosphere, released material, and then said, what happens in that setting? And what does that mean for the resulting size distribution? And what the implications of that, if you use the UK climate model, UK ESM, and you use CSM, the Community Earth System model out of NCAR, and in each of them you say, we want to produce a given amount of cooling. Let's say we want to hold temperatures flat at 1.5 degrees Celsius.
Right.
They actually produce pretty similar plots of what that looks like. So, if you're saying we want to hold temperatures at 1.5 degrees Celsius, that is a global average temperature. And then you're going to see some distribution of some places will be a little cooler than that, a little warmer than that. And these two models produce roughly similar maps of temperature. They agree on precipitation to a large extent. Where they disagree is that they disagree by a factor of 2 on how much stuff you have to put up there to produce that amount of cooling. And this is that aerosol size distribution. They have very different assumptions around the aerosol sizes. That has real implications.
Yeah, that's pretty basic. I mean,
It's
a
pretty
factor
basic.
of a factor of two is
Yeah.
yeah.
If you put up 2 times as much stuff, 2 times as much stuff is going to come out. So that may have implications for ecosystems, for human health. It certainly has implications for what would be required, the physical infrastructure that would be required to do it.
Mm-hmm. Or what if you inadvertently get twice the cooling you think
Exactly.
you think you're going to get?
Exactly. So that the aerosol size distribution uncertainty, if you look at this database that we've released, you'll see that it is it is far up and to the right, because it is something that we think is
Very important and very uncertain.
Exactly.
Got it. And then so climate response, I guess, is pretty obvious. Like, what are the other climate systems going to do in response to this? Earth system, I'm guessing, is like hydrology and plants and stuff. What they do, and then what's engineering? What's that about?
Yeah. So engineering is sort of, how would this be done? And do we actually, there's a sort of interesting thing where, despite people using the term geoengineering to describe this whole field, there's actually been very little engineering work done. And so there's a huge number of assumptions about what is feasible. One, sort of oft quoted and pretty obvious example, most of the scenarios that have been modeled assume that you are flying an aircraft up to 22 kilometers and releasing material at 22 kilometers.
And is that where the troposphere becomes the stratosphere, right around there?
That is a couple kilometers above what's called the tropopause, the zone between the troposphere and the stratosphere. The tropopause is much higher at the tropics or at mid-latitudes than it is at high latitudes. So these scenarios have assumed that you are releasing near the tropics at 22 kilometers, which is just over 72,000 feet. And for those here who think about aviation, you'll know that that is much higher than commercial aircraft fly, and it's much higher than really any large payload planes that we have currently. And so we don't have the aircraft that would be required for the scenario that is most commonly modeled.
So we're talking about building new kinds of planes?
If the goal is to deploy at the tropics, yes, you will have to do new aircraft development. What's interesting, I just mentioned that the tropopause is much lower at the poles. And so it is hypothetically possible to loft material, in either the northern hemisphere at high latitudes using existing aircraft.
But then you have to know, are they going to spread all the way down to the tropics? So I guess this gets back to Earth system response, but this is an interesting area of research to me, which is that I think people who think about climate change are used to thinking about global effects, basically. Carbon dioxide, famously global, it affects everyone equally, but this is not necessarily global. Or rather, we don't necessarily know how global it is. In other words, like if you dump a bunch of these things up by the poles, will they spread down and shelter the tropics? How regional is this, I guess?
Yeah. So how SAI is deployed matters enormously. There are stratospheric circulations that will move material around the stratosphere. And what research has shown is that material injected in the tropics essentially is circulated poleward. And so if you put material into the northern hemisphere, that will get circulated towards the North Pole. If you put material into the southern hemisphere, that gets circulated towards the South Pole. And these are pretty well understood large-scale dynamics. But there's an interesting thing in that. First, as you know, because it moves poleward, we don't see much crossing of material over the equator. So if you put stuff into the northern hemisphere, you can cool the northern hemisphere. And if you put stuff into the southern hemisphere, you can cool the southern hemisphere. But you would need to be putting material into both hemispheres to cool the planet.
I got it. So there's no prospect of a single source of this affecting the entire globe. Like, it's probably physically impossible, we think.
Well, it would affect the entire globe. It wouldn't cool the entire globe.
I see.
So one thing that feels pretty evident looking at modeling, and this is a topic, this is not a new topic. This is something that LBJ and his climate advisors were talking about in 1965. There's been decades of modeling work done. And, pretty consistently what is shown is if you cool significantly in only one hemisphere, you end up with cooling in that one hemisphere, no cooling in the other. And that can lead to really material, and I would argue just sort of obviously deleterious impacts for precipitation.
Oh, interesting. Well, can you generalize what exactly?
Yeah, so if you cool evenly, what you see is you're not resetting the clock to zero. You're not just turning down the temperature, but relatively even cooling doesn't seem to lead to any particularly drastic changes in precipitation patterns. I should note, though, that that is looking at it at the 10,000 foot level.
Right, right. And these are the big models.
These are bigger systems models. If you cool in only one hemisphere, there's this thing called the intertropical convergence zone. And you can basically move the ICTZ up or down based on relative temperatures between the two hemispheres. And you could imagine if rainfall shifted significantly north or significantly south, that would threaten food production for hundreds of millions of people.
Yeah.
And so that is, I think one of the pretty clear things is that even cooling is going to be important if this is ever pursued.
Yeah, I mean, I guess one thing to keep in mind is the things you're talking about are capable of producing relatively rapid, relatively large changes in climate systems. And we just know that, like, human beings are not, we cannot adapt to those things rapidly. I think a lot of people are sort of like, well, how do you even test this without risking, sort of horrors? I think people are sort of people have trouble imagining what are the incremental steps. One of the things you've written lays them out really interestingly in an analogy to what they call the 3-phase trial framework in pharmaceuticals. So maybe you could just take us through that analogy and what it would look like to do phased research. What would the phases look like?
Yeah. So, we'd argue that SRM research needs a framework. It is unclear at this point what work can proceed, under what conditions, who must be consulted. And I think that creates this dangerous catch-22 where responsible researchers are trying to satisfy this amorphous, ever-expanding list of governance demands, careful, small experiments that might actually answer really critical uncertainties aren't moving forward. And meanwhile, the risk grows that less scrupulous actors will bypass these debates altogether.
Yeah, we're going to discuss some of those later.
Yeah, they'll conduct large experiments or deployment without oversight. And medicine faced a similar dilemma. And, really the introduction of phased clinical trials was a response to that. How do we ensure that there is a way to test incrementally that a drug is safe and effective before we roll it out?
Right, without potentially sacrificing the lives of the testees. Right?
Exactly. And so the idea is a disciplined pathway that, can minimize undue risk by sequencing experiments and requiring review at each step. This helps to prevent the slippery slope concerns because there's explicit stop or continue criteria, while also producing the evidence that policymakers need to evaluate whether this is a good idea.
So what would that first phase be? Like, how do you do a small experiment on the atmosphere? It's quite large. Like, what does that look like?
So I'd argue phase 0, preclinical is where we are now. And that's advanced modeling. That is ensuring that multiple research groups around the world are sort of asking the questions that matter to them about potential impacts and flagging things that might be a concern, and identifying what uncertainties move policy decisions, what we've been trying to do with the uncertainty database. Phase 1 would be a small experiment that is actually designed to address the uncertainties that we were just talking about around aerosol size distribution. The idea would be to observe whether aerosols, when released from a plane, behave as models predict. How do they form and evolve in those first few days after an injection? And this would require, best estimates are somewhere on the order of 10 tons of SO2. This is so much smaller than something that would affect climate. It's less than 1.5% of what planes, just as part of daily aviation, emit each day. But it would be large enough that you would be able to observe all of this.
I see. So you're not, that first phase, you're not even really studying impact. You're just studying what do the aerosols do when we let them go.
Yeah.
And you can do that with a relatively small amount of aerosols.
Yeah. Phase 2 would also not be at the scale of studying impacts. This would be at a scale that is too small to produce any meaningful cooling. It would be smaller than volcanic eruptions. But the idea would be to track the distribution of those aerosols over months to see if the aerosols go where models predict they will.
Right. Based on these stratospheric circulations.
Yeah.
How do you track a aerosol particle? It's quite small and invisible. How are these being tracked?
Well, I should say nobody is doing this yet.
Right.
But there are instruments that we can use. They're satellite-based instruments that allow us to just detect that there is SO2 in kind of increased concentrations in the atmosphere. And then you could imagine using in situ observations. So a plane with a whole instrument suite that could then fly through the plume from the lofting aircraft in order to sample and collect all of that data.
So phase 1 is just what do aerosols do immediately upon release? Like, how do they behave? Phase 2 is then tracking the circulation of aerosols, both of which you can do without any particular risk of having any particular effect on the climate. And then what's phase 3? Hey there, everybody. Don't worry, I'm not going to tell you about a new mattress or push a credit card on you. This isn't an ad. There are no ads on Volts. It is supported entirely by listeners like you. If you'll indulge me for a second, I'd like to ask for your support. I started Volts because we're all surrounded by depressing news about climate change and misinformation about clean energy, and it's never been more important to share the stories of the real people on the ground doing the real work of transition and all the ingenuity and courage and public spirit they are bringing to it. People are hungry to hear these stories, to learn from and find inspiration in them. I've heard from people who changed majors or careers after hearing episodes of Volts, people using it in classrooms and community groups, even state legislators who have passed bills inspired by specific episodes. Sharing these stories matters. It makes a difference. If you have found value in it and want to help me continue doing it, I hope you will join the community of paid subscribers at volts.wtf. It's about the cost of a cup of coffee a month. If you don't like subscriptions, you can make a one-time contribution, leave a review on Apple or Spotify, or just tell a friend about Volts. I am grateful for any and all support. If you're already a paid subscriber, thank you. And now, back to the show. So phase 1 is just what do aerosols do immediately upon release? Like, how do they behave? Phase 2 is then tracking the circulation of aerosols, both of which you can do without any particular risk of having any particular effect on the climate. And then what's phase 3?
So this is where the analogy breaks down a little bit. And, this is an imperfect analogy. All analogies are, but we don't at the moment see an obvious phase 3 analog in SRM. Instead, I think at that point, the remaining open questions would be things you could only observe once you had decided you actually wanted to produce a little bit of cooling.
Mm-hmm.
And so in medicine, there's phase 4 post-licensure monitoring. They've decided, the FDA has approved a drug. It's out there. People can be prescribed it. But there's things that you might not detect until it is in a much larger population. And so we think there's a phase 1, there's a phase 2, and then there might be that decision to
go or no go.
Go or no go. And at that point, that's not we're going to start cooling by 0.5 degree tomorrow. It would be a very gradual increase in injection rate over a decade or longer. And during that whole period, continued monitoring to say, is there anything that, we didn't expect?
Because you're talking about monitoring, and I think that's so vitally important. Are there, what are the kind of pieces of a good monitoring system? I mean, among other questions I have is just who's doing this? Who monitors? Who do all the countries of the world trust to engage in this in a transparent way? And then just technologically, what do we have to have in place before we're doing good monitoring?
Yeah. So on the monitoring side, there are existing satellite instruments. We have a handful of valuable instruments for in situ monitoring, but there is a pretty significant gap in our monitoring capabilities, and that is only going to get worse. So one of the satellites that is used to monitor this, and I should say when I monitor this, like to monitor SO2 and sort of study atmospheric composition, is the Aura satellite. And this is a microwave limb sounding instrument, and it has been sort of a central piece of all of our SO2 monitoring now for decades. It was launched in 2004 and was meant to have a 5-year lifespan. Obviously, we are well outside of that window, and it will go out of commission soon. And so I think there's a very vital piece here around how do we ensure that the monitoring capabilities, and these are not just important for a scenario where SAI is deployed, these are important so that we better understand our atmosphere and we better understand the implications of warming.
Well, I just wanted to interject here with a line from one of the papers you wrote that really made my eyes bug out. So just give people a little bit of context to all this stuff we've been talking about. It says the world currently emits 80 million tons of sulfur dioxide, and that's all going into the troposphere. If a quarter of that, 20 million tons, went into the stratosphere instead of the troposphere, both the warming since the Industrial Revolution and all the future warming we expect would be balanced out. That is quite striking. So if a quarter of existing sulfur emissions were redirected to the stratosphere instead of the troposphere, that wipes out all historical warming. That is striking. I would just say, I don't even have a question. I'm just struck by it.
If we take a step back, the Earth's warming is dictated by an energy budget and an energy balance. And there's sort of bad news on all fronts on this. Earth is becoming less reflective.
Yes, it's getting worse. I don't know if people know this.
It is getting worse. And we usually think about climate in terms of greenhouse gases are trapping more outgoing heat. And that is why most of our policy has focused on what we should do on that side of the equation. There's an interesting thing where counterintuitively, the Earth is also radiating more and more energy into space. So Earth is becoming less reflective. The main suspected driver of that is declining cloud cover. But, we would expect to have less heat escape in a world with increasing greenhouse gas concentrations. But the Earth is actually radiating more energy into space. Outgoing long-wave radiation has gone up significantly since 2000. Multiple factors could contribute, but here too, declining cloud cover is potentially a really important contributor. And so we're in this position where we're messing with some of these systems in ways that we don't understand.
Yes, we are geoengineering.
We are certainly geoengineering.
Everybody should understand that.
And the challenge is we've now seen the significant decline in reflectivity. That has real implications for warming. These acronyms are stacking up. I apologize. But we use the term Earth's Energy Imbalance, EEI, to talk about that gap between energy coming in and energy going out. And since 2001, there's been a net increase in energy imbalance of about 1 watt per meter squared. That's nearly twice the increase predicted by climate models.
Yes.
And it's equivalent to increasing atmospheric CO2 by 86 parts per million, which is a huge amount.
Yes. This is kind of what's going on right now, is that the Earth system is responding more dramatically to greenhouse gases than the models say. This is sort of the ongoing mystery in climate science, is why are we seeing effects that seem more severe than what we would expect from the models? What you're saying is that reflectivity is part of this, cloud cover might be part of this.
Yeah. And so, the net of all of it is what you just led with, which is somewhere on the order of a quarter of today's annual SO2 emissions, if delivered into the stratosphere, would be in the range needed to counterbalance this.
I know people get this already, but just as a footnote, when we say balance out, we don't mean wipe out the effects of, right? You still have ocean acidification, et cetera. It's just the heat of it. Although the heat of it is not a small thing.
Yeah. No, I mean, it would not cancel out greenhouse gases. It would not restore a pre-industrial climate. This is admittedly, and I don't want to say proudly, but like this is clearly a Band-Aid.
Right. So I think a lot of people are just intuitively thinking, well, when we put these particles up here and call them pollution, they're doing all sorts of bad things, right? Pollution has bad effects. Throwing sulfur up into the air has bad effects. It causes ozone, holes in the ozone, and respiratory problems. And, people think of pollution negatively. And so if you're talking about deliberately basically throwing a bunch of pollution up there, I guess people's mind automatically goes to, well, will this not make all that worse? Will this not have all the ill effects that pollution has? Will this affect our respiratory health? And also, will it affect plants? Like if you're measurably reducing the solar radiation reaching the surface, are you affecting the performance of photosynthesis? Are you affecting the performance of solar panels? Just like, what are the possible negative effects, I guess, of doing this?
Yeah. So vis-a-vis health, I'll start there. I think the trade-off that people are thinking about, and this is a, sort of reductive initial way to try and think about some of the health implications, is if you add a small amount of sulfate to the stratosphere, what will be the effects on respiratory health when that precipitates out? Versus how will that same amount of sulfur reduce the mortality associated with extreme heat events?
Right. What a macabre cost-benefit analysis.
Absolutely. I mean, the hard thing, I think, in thinking about the risks and impacts of SAI, and this is true for, any sunlight reflection method, and I think probably true for, many of the trade-offs that we're considering around climate policy, is that you have to be thinking about this kind of risk versus risk analysis.
Right. There's no non-risk.
There's no non-risk. There's the risks of doing something. There's the risks of not doing something and having continued sort of unabated warming. And so on that particular measure, there's been research showing that for every one additional death that you would see, due to those respiratory effects from the sulfate, you would save 100 lives due to heat-related mortality.
Interesting. So that's pretty, maybe not precise, but pretty clear, at least directionally.
Directionally. There's so much more work that's required to dig into that further. Another thing that people talk about is ozone and ozone, potential interactions with ozone depleting chemicals. So sulfate aerosols do interact with stratospheric ozone chemistry. That's a known concern. And I think one of the things that people have worried about is, basically we've put a lot of work into trying to, course correct from the ozone hole. And if this in any way kind of caused a backslide, that would obviously not be good. There's a few interesting pieces here. One is that we're on track for a super recovery of the ozone hole.
What does that mean?
That we're going to have more ozone than we did. So we're going to have more ozone than we did. And with that, the sulfate particles would interact with these ozone depleting chemicals. Because we've done a really good job of arresting the use of those ozone depleting chemicals, like if somebody ever decides to deploy, when that happens, there will be different concentrations of those chemicals in the stratosphere. And so there's sort of important implications to when deployment might start, and hence, what those potential interactions would be. But there is at least in some of the research, it suggests that because we are on track for a super recovery, all it would do was delay that by a couple years.
Interesting. So we can spare, if I can crudely summarize, maybe we can spare a little ozone?
I want to be careful about saying that, but it is a concern that I think many researchers feel is overblown.
Right. Interesting.
It is also a reason that alternative particles get discussed, like calcite.
We kind of skipped past that, but I guess I would just ask that now. Is there even the prospect of us being able to sort of custom design particles to do the things we want them to do and not to do the things we don't want them to do? Is that even a thing?
Yeah. So, we focus on sulfates because it has a natural analog. Volcanic eruptions are not a perfect proxy for what an SAI deployment would be, but they do provide real world constraints on what would happen if you were to release sulfate aerosols. What would those climate effects be? There is work ongoing to explore other natural, sort of aerosols. There's been research around alumina and calcite, et cetera. And then, there is a group Stardust, which is a private company. They have not released any science, so it's hard to dig into this, who has been trying to do essentially what you were describing of can we engineer a particle to meet a certain set of desired criteria.
Mm-hmm. So I'm guessing as just a nonprofit research organization, you're probably agnostic to this. Like if a better particle comes along, you're fine.
Yes, I think, our sense is sulfates make sense to study as a sort of Gen 1. We think that there's finite time and finite resources available until we think decisions about this could be on the table. And given that, sort of prioritization and focus is a necessity, we'd rather well understand something than poorly understand lots of things. And with that, we basically said because sulfate, has this natural analog, we understand it relatively well. It is the thing that is most commonly discussed. It's likely to be on that agenda. And there's a pretty clear critical path to producing the decision relevant evidence. More novel particles may eventually matter, but they do add new unknowns in terms of chemistry or feasibility and monitoring. And so
then you have to do your whole phased research all over again.
Yeah.
Just to return to the question before we move past it, would this affect photosynthesis? Are we talking about blocking enough solar radiation to measurably affect photosynthesis or to measurably affect the performance of solar panels?
Yeah, so there's actually really interesting evidence on plants and photosynthesis, which is SAI diffuses some sunlight. It reflects some and it diffuses it. And that actually in, sort of large scale crop models leads to better crop yields, not less. Plants like that sort of more diffuse light.
Interesting.
And so counterintuitive, but, generally the sense is, you're in an environment where there is more CO2 and diffuse sunlight.
We understand that dynamic well enough to say with some confidence that this might boost rather than restrain photosynthesis?
That is a gross oversimplification, like all of these are. Different plants respond to different things. You will see regional differences in the amount of cooling. You'll see regional differences in precipitation. Those in aggregate need to be studied. This is, we're at a point in the research where, we know sort of big, broad strokes things, but those specific questions really, really matter.
And solar panels, has anybody done the research on that or tried to estimate?
I would need to go pull up more research on this. But the Earth naturally reflects about 30% of incoming sunlight. And, even in the proposals where people are saying let's cool pretty significantly, they're talking about an increase to reflecting 31% of incoming sunlight. And so the sort of net effect on solar panels will be modest.
As you say, the sort of officialdom is moving slowly on this stuff, and there's not really a structured research program that's been given kind of a legitimate thumbs up from all the legitimate organizations. And so consequently, there's some kind of cowboy activity happening around the edges. There's this private company that's popped up called Make Sunset, where you can now literally send them I think it's like $10 or whatever, and they'll send a little balloon, a little balloon of particles up for you. I mean, that's kind of ridiculous, but also it's kind of sinister, I think. Mm-hmm. So what do you think our collective response should be to those types of things? Like, I'll just say my instincts, my priors are that we should sort of go overboard to shut that down and to try to channel this into some common, central, transparent, shared thing. But am I overreacting? Like, how do you think about that?
I don't think you're overreacting. I think there are sort of two companies active in the space right now. Make Sunsets, you just referred to, as one of them. Stardust is another. And I would treat them as quite distinct. I think Make Sunsets is, as you say, you can go and give them $10 and they will release a small weather balloon with a nominal amount of SO2. And, it is not an amount that will cool the planet. Far, far, far from it. They're also not doing any science, right? You're not learning anything in that process. So it is neither improving the quality of our information nor actually producing cooling. And I don't see a pathway for, it to kind of evolve to support either of those goals.
I mean, I think maybe they would kind of say they're just kind of doing a stunt to push everybody else to take this more seriously.
I think that's true. I mean, I think that they would say this is, the time is nigh and everyone is, essentially being too precious about all of this, and that they are trying to,
Nonetheless, I have the urge to tell them to go to their room as
do I.
with Silicon.
As do
Hush
I.
up, go spend some time in your room and think about what you're doing.
And I think that, as you said, there is sort of significant pushback against that very rogue kind of cowboy actor.
Well, curious what you think about Stardust. They seem a little bit more, I mean, at least they're scientific.
Yeah, so they have a different scale of funding. They have a different level of seriousness, and they might be doing good science. Given the pedigrees of the folks on their team, that feels plausible.
And I think they're supposed to be coming out with stuff next year. Like there's supposed to be a big release of their early.
Yes. I mean, it is impossible to know because they're not releasing any science publicly.
Right.
And in a field where public trust is fragile, that lack of transparency poses a risk not only to them, but to the entire field and to efforts to responsibly learn about this whole, about sunlight reflection.
It really does seem like, especially in this area, you just want to overcorrect in the direction of transparency in these early stages. Like if you want this to go anywhere, you really need to scrupulously be open about it. It seems to me like that's my instinct.
I could not agree more. For us, we publish all of our funders on our website. We have made, we are publishing all of the research that's done. We put out the uncertainty database. We've released the simulator, all of them designed to kind of lay bare what we know, what we don't know, what we think it will take to get to the point of informed decisions, who's guiding those decisions, who's guiding our thinking. The transparency is absolutely critical. And I think there's another piece, which is, with Stardust, the profit motive itself is sort of structurally problematic, not because companies are inherently bad. And, I think there's...
Well, I mean...
yeah, we can have that debate later. But even in a scenario where, research exists entirely in the public sector, at some point, if there is a decision to deploy, there will be companies involved. Somebody will have to develop those aircraft, for example.
Yeah.
But in the absence of any independent authority with the capacity to evaluate claims, there's a real risk that Stardust or any other private actors overstate their particle safety or efficacy to cut a deal, and that could lead to very real consequences. I think going back to the medical analogy, there's no FDA equivalent.
Yeah.
There's a good reason the FDA exists, and without that, the incentive structure is dangerous.
Yeah. So I kind of want to address what I feel like is one of the knottiest and most difficult aspects of all this, which is the sort of who decides, who's in charge kind of thing. So there's recently a call by governments for a solar geoengineering non-use agreement. And ministers from 54 African nations signed this. So there is already a lot of sentiment, I think, in the global South that here they go again, the global North, presuming to take charge of the temperature of the frickin' globe, without consultation, with doing things that affect our countries without asking us. This is obviously a whole nest of difficult issues about colonialism and et cetera, et cetera. So this is where my brain breaks on this stuff. How do you even think about trying to get the degree of sort of international cooperation you would need to really have this be fully transparent, fully common thing that we're all involved in? We can't agree on anything, Dakota. We can't, you know what I mean? Look at the U.S. right now. I mean, even assuming we get a better regime in the U.S., how do you get everybody on the same page like that? How do you think about that challenge?
Yeah. So I want to be precise about this because the framing matters. The non-use calls are primarily driven by European NGOs. They're not coming from African scientists, African research institutions, or necessarily originating with African governments. In fact, the opposite is happening. after an article was run suggesting that this was really being driven by researchers and policymakers on the continent, over 30 African climate scientists signed a public statement saying, and I'm quoting, excluding African scientists from global research conversations would be far more colonial. And
so we have European NGOs using African countries as basically tokens or shields for their own ideological preferences. That certainly does not strike me as outlandish.
Yeah, the point is research needs to be inclusive and decision making needs to be inclusive. And there's really important work ongoing to make that real.
But what does that look like, though? Is it a framework? Is it an organization? Is it like a list of principles?
Yes, and. So I'd say, some of the things that are happening at the moment, there's a recently launched African Climate Intervention Research Hub that's really kind of stewarding this within the continent. There's an organization called the Degrees Initiative that we work closely with and love that funds researchers across the Global South to study SRM. We ourselves have funded researchers in 6 countries outside of the US and soon to be many more. So I think there is a lot of work ongoing to ensure that the evidence base and the people producing the evidence base isn't exclusively Northern. That doesn't get you to the point of who is making the decision, but it does improve the quality and the inclusivity of the evidence base itself. In terms of the sort of where these decisions should be taken, we see a future in which intergovernmental or multilateral processes take up responsibility for SAI research and deployment decisions as the scenario likeliest to lead to good outcomes.
And do you mean by that the UN, or are you deliberately not specifying the UN?
I think that the sort of existing institutions that people look to, whether it's the UN or the Montreal Protocol, I don't think any of these are sort of credible or desirable answers. They're not designed to sponsor experimentation, nor do they have the mandate or capacity for ongoing management of something that is like ethically and technically complex. The question becomes, what are models that might be appropriate we can draw from other sectors? Because I think something new will need to be built.
Well, I think one of the things that climate heads are probably thinking right now is whatever you do, don't put it in a context where you need unanimity among all the world's hundreds of countries to do anything, because that's what we set up.
We're not in a world where unanimity happens on anything.
That's what we did for climate change, and consequently, the UN did nothing for decades on end because you can't get unanimity. So, again, we're on this I guess there's no sort of flat answer to this, but you're on this sort of trade-offs. You're never going to get total unanimity to do this, I don't think. So what counts as enough unanimity to pull a trigger on something that affects the entire globe,
I think it is valuable to think about sort of an incremental, one of the challenges that you see is there's this chicken and egg around solving the governance challenges and trying to understand what we are actually governing. And so there's, there have been attempts to preordain what the governance structure should look like to govern scale deployment. And the problem is, that might be designed for something that, quickly the science rules out.
Right.
And so we think about it more as sort of an incremental pathway where you're developing governance and doing the research in parallel and kind of in lockstep. And so with that, I could imagine essentially a coalition of the willing that is a group of countries, and I think it's important that it's countries, who pool resources in order to fund research. And part of pooling those resources is then saying, okay, we're going to openly debate the priorities, and we're going to work together to define those endpoint criteria for experiments. And in that, you get a group of countries who are cooperating in a very open and transparent way before consensus or without consensus.
Yeah, it would be nice. It would be nice to have that kind of rational organization addressing a variety of problems I can think of globally.
I hear you. And I don't think this is unrealistic. The world that I come from, I mentioned earlier, I started my career in vaccine policy and worked for an organization called Gavi. And Gavi was launched in 2000 to address fragmented funding and legitimacy gaps in terms of vaccine delivery. And, it was really designed in a way that I think is pretty instructive. No one thinks of it as a governance organization per se, and yet that's precisely what it is. Their board transparently wrestles with amazingly complex and very consequential questions about, do we support Japanese encephalitis or do we support malaria? And that has real implications for whether kids are being protected, and where kids are being protected. Their management of their programs is adaptive. This isn't the sort of set it and forget it model of a treaty. There's a secretariat with real technical depth, ensures that the decisions are scientifically grounded. It's this sort of focal point that discourages duplication and makes cooperative governance sort of easier. And I think that's important in SRM because without some type of pooled research fund, the field is likely to splinter into national research programs that may have competing priorities or methodologies.
Beyond that, nations who decide to go for it.
Right. And that increases the odds of, unilateral or poorly coordinated action. And so if you have this pooled research alliance, that creates sort of a forum for those trade-offs to be surfaced and debated in something that's sort of inherently multilateral from the get-go.
Yeah.
And I think probably the last thing to know about Gavi is it, at least apocryphally, emerged over a dinner. It was not the product of long UN deliberations. It was this is a thing that we think should exist. Let's go create it.
The last question is just then about the termination shock, since that seems like a good closing place. So one of the kind of sci-fi-esque fears about this is once you start doing it, you're stuck doing it. Yeah. You got to keep doing it or else the warming comes back all of a sudden. So in addition to thinking about this multilateral incremental way of edging up to it, somebody's also eventually going to have to think about multilateral incremental ways of undoing it at the end, right? Somebody, presumably this will buy us time, we'll decarbonize, and we'll need less cooling, and then we'll ramp down this sulfur injection. That's sort of the vision, right? I mean, we ramp it up and then we ramp it back down. But then you get into who decides what the right temperature of the world is? It's a way too big of a question to throw here right at the very end. But once your collective hand is on the thermometer, right? Yeah. Then you own it. You break it, you own it, right? Then you own the temperature of the Earth. Some regions would benefit more than others from more or less heat, right? So once you're already doing it, then have you thought through how to deal with those governance challenges or how to decide what the right sort of target is?
So I think termination shock is a legitimate concern, and it's one of the strongest arguments for doing this research really carefully. Yeah. Maybe not so much in the scenario that you're talking about of, great, we've actually managed to see the progress we want on decarbonization. We've seen CDR scale to the point where it's meaningful. And we are now carefully considering when and how to start ramping down. The concerns around termination shock are often in the vein of you deploy at scale, and then you learn something you didn't want to learn. And, there's a very abrupt stop, or it introduces sort of a geopolitical risk that causes an abrupt stop. On maybe the first of those, on you learn something and then there is good reason, there's reason to stop, and that leads to rapid warming. I think that's part of why this clinical trials model, and particularly that phase 4, is so important. You'd want to ramp up very slowly and monitor so that if things diverged from predictions at any point in that ramp up, you'd still be at a scale where you could ramp back down pretty easily and without termination effects. In terms of the geopolitics, I think that is an argument for why multilateralism matters so much. I will just keep banging on about that. And then in terms of ramping down, It is and careful, intentional. I'd like to think that if you have a group who is weighing the really complicated trade-offs and decisions about how much cooling to do, it is just a continuation of that same, set of decision-making criteria, right?
Yeah. But that's a lot of trust you're asking for there. A lot. Like, let us set the Earth's temperature. That's, you're putting a lot of trust in that group.
That's why it needs to be well designed.
All right. Well, Dakota, this has been super, super fascinating. And, I look forward to seeing this. I hope it moves forward in as multilateral and rational a way as you as you propose. I'll just say that.
Well, thank you so much for having me.
Thank you for listening to Volts. It takes a village to make this podcast work. Shout out especially to my super producer, Kyle McDonald, who makes me and my guests sound smart every week. And it is all supported entirely by listeners like you. So if you value conversations like this, please consider joining our community of paid subscribers at volts.wtf, or leaving a nice review, or telling a friend about Volts, or all three. Thanks so much, and I'll see you next time.